The importance of seismic protection when designing for extreme conditions. Welcome to Building Knowledge 101. In this video, we explore the importance of seismic protection when designing for extreme conditions, as well as understanding the nature of seismic activity on a building can help minimize the risk of property damage and protect human life. So if we're looking at this map shows various seismic zones across the United States. Zones that are established on a scale of 1 through 5, designating increased risk of occurrence of seismic activity. Zone 1 has the lowest risk of seismic activity, while Zone 5 has the greatest risk of seismic activity occurring. We all know the impact of seismic activity, or what the impact that earthquakes can have. Here's a picture of a parking deck that folded over during an earthquake. The damage from seismic activity can be massive in terms of capital and human loss. When we evaluate the impact of an earthquake upon a building, we talk about what's called story drift. The frequency of waves from seismic activity can cause a building to shake. In a worst-case scenario, as the building shakes, each story can slip back and forth in different directions. This is what we refer to as story drift, as the floors stack up above each other, moving back and forth in different directions. The red lines here illustrate story drift of a building. As the building shakes back and forth, the middle floor is shifting to the left, while the floors above and below are shifting to the right. A typical curtain wall is mounted to the exterior of the structure and anchored back to each floor line as it passes it. As the floors drift back and forth, the anchors of the curtain wall pull the frames with them. The glass in the frames is dead loaded on the horizontal and tends to sit still. As the verticals begin to tip back and forth, glass moves with the horizontals. This is what story drift test does. It tries to replicate verticals moving side to side while the glass stays centered on the horizontal. We looked at it in one direction, now it shifts back the other direction. So let me now kind of illustrate what that looks like. The verticals moving back and forth during story drift till eventually they come in contact with the corners of the glass unit, causing them to break. So here you can see I've illustrated the verticals moving back and forth, and the glass sits on the horizontal. The horizontal doesn't typically move, it's the verticals. And as the verticals begin to move, as their sway increases, eventually they're going to hit the edge of the glass and start to break the glass. So let me show you another illustration. Let's look at an animation of that. You can see our building shaking back and forth and the slabs moving from side to side. So this is an exaggerated illustration of story drift, but this is what occurs to a building during seismic activity. So your curtain wall has to be designed with large glass pockets with systems that are designed to slide, the verticals slide past each other, joints, anchors that allow for movement, and large glass pockets around the glass to allow for movement of the frames before they come in contact with the glass units, breaking them. Typical curtain walls are designed to float on the head and sill anchors. Typical F&T anchor is hard fastened to the surround, while the verticals slide up and down over the anchors. This type of attachment allows limited movement of the curtain wall within the elevation while remaining secure in the opening, protecting it. A typical perimeter joint around a curtain wall is 1/2 of an inch. Based upon the amount of movement anticipated, joint sizes might have to increase to absorb more movement. You can see in the illustration on the left that we've increased the size of the joint at the head of the curtain wall to accommodate more movement. The anchor detail in the center shows how the top of the vertical stops shy of the anchor, increasing the amount of space there, allowing for greater amounts of vertical deflection to occur. In high seismic areas, unitized curtain wall is an excellent approach. Unitized systems are fabricated off-site in modules that are assembled and glazed. These then are brought to the job site and assembled module by module at the project, as you can see here. Each module is independently anchored to the building, to the structure, and can move independently. It's a two-piece vertical that interconnects at the job site when the modules are snapped together, so it allows the two halves of the vertical to slide past each other as the mullion starts racking back and forth. Then each module is hung resting on top of the one below it, allowing for vertical deflection. So in a seismic area, unitized curtain walls are again very, very popular. This is a split vertical. You can see the illustration on the left there. Here are the interlock points between the two halves of the verticals. Because the two halves just interlock with each other, the halves can slide alongside each other during story drift. As a mullion tips to the side, the two halves slide and tip independently. This reduces the impact of story drift from one light to the next. And here's another example of a unitized curtain wall. Unitized curtain walls perform very well in seismic conditions because they're built-in modules that allow slip and movement between them. This last detail shows you the horizontals with stacked together. This type of stacking allows for movement to occur between them. The other half is hanging from the floor above and not load-bearing on the lower one. This is a unitized fabrication. It leads itself to very strong performance in seismic application. Most curtain wall manufacturers can simulate the performance of the systems based upon story drift value for each project. It is best confirmed early with the manufacturer that your design will perform as anticipated with their individual system. But again, in seismic areas, unitized systems allow for greater movement than your typical stick system. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.